This video demonstrates how to use Visicon's clash detection operation. We'll start out with a model that I preloaded with three different Revit models that were merged within Visicon. We can see those models either here. We have three models that I can turn on. There's a mechanical model, a plumbing model, and a structural model. So we'll turn all three models on. We go under the model icon of the project browser, and we can see that each one of them has we've given them a unique name. So this is mechanical, plumbing, structural. Clash detection falls under the operations part of Visicon, and before we actually go into the operation and define the operation, let's go set some of the other environment parameters. So first thing, you'll see that when we create an operation, we can assign it to individuals, and we can also mark who actually created the operation. So in this case, we'll create a clash detection operation between two specific component types, and then any clashes that are detected will generate an issue that's assigned to somebody. So we'll start by just creating some users. So here, for example, we'll give that to, let's say, myself, John, and Sally, for example. I can give it some additional information. We can also define groups. So for example, this could be Acme Construction. And I can then tag and say, for example, John and Sally are part of Acme Construction. So any communication or any tagging that I can do, I can choose to either tag something to a group or to individuals. The next part of the operation that we need to work with are filters, because each operation type has as an input a set of filters, or let's say a group or selection of objects. So let's go ahead and explore filters. I'm going to change my color to just the material at this point, and so let's go and just create some basic filters. So the way it works is I've now created a filter. I can pre-select, so these are all the different object types that are available in this model, so I can already very easily pre-select different components that would be excluded from a particular filter. I'm going to, in these examples, always leave the entire filter set or solution set open here and just focus in on the use of expressions. So I have a filter name. I give it an expression. Each filter can then be used in different parts of the program, and then I can also add comments. Also, for every filter, I can add exceptions. So if there are particular objects that would fall under or qualify for the expression, I can still manually exclude those by adding those selecting objects that are falsely still being pulled into a filter and exclude them. So let's go ahead and start. So the way it works is, once I have my filter selected, and let's give this one a name, and we'll just call this our mechanical model. So the way I would say is I can write an expression, so I could say any object, and if I look, for example, here, let's select an object, and you can look at all the parameters, and you'll see the expressions are written with respect to properties, parameters, or families. And again, parameters and family values are only imported if you do the full export from Revit. We also auto-generate and pull family parameters from etabs and the adapt file as well. So I'm scrolling down and I see every object is classified by the model. So here I can see there's a model and structural. So what I'm going to do is I'm going to come and say, okay, so any object whose model name equals mechanical. So now you see it's pre-selected, and there are 18,292 objects that meet this category. So I'm going to come in and we'll take this and clone. So we're going to call this one our structural model. We're just going to come in and modify this and call this structural. So now it's select the structural. We'll copy again. We'll call this our plumbing model filter and go into plumbing. The way operations work, you'll see that I can, there'll be an input, let's say, or an A against an A category that's clashed against the B category, and for each of those categories, I can also define compound or multiple filters that get applied. So a good example of that would be, let's say we want to only coordinate all of the components in the upper levels of the structure and not below. So I'm just going to come in here, I select a level, I scroll down, and I can see that's about 917 feet. That's the elevation or the Z coordinate of those components. So if I want to select and only clash what's above, what I'm going to do is I'm going to come in and create a new filter, right? So the benefit here is I don't have to add that additional logic to each of these individual filters. So I'm going to call this above, and we'll just take a value here. We'll say above 915 feet. So now I can come in here and I can say object dot minimum bounds. I can give any of its parameters. So I say Z is greater than 915. And so this automatically selects any object whose lower bound is above there. So I've now established some very simple, parameters. I can, let's say we'll go in and do one more. I can come and say, for example, let's say I want to just pick objects that have a length of less than 3 feet. Again, I would come in and I say object dot, and again, if I select any of these components, and this applies, for example, a slab or floor does not have a length, so this would apply to any, let's say, piping object or so. You see, let's see if I select a pipe object, you see it has a length parameter. So I can come in and say object dot length less than 3, and so that has isolated and selected any of the components in my structure that are less than 3 feet. I can go under home, also isolate, and so this now shows me all of that selection set, right? So now each of my selection sets is visualized and isolated. So we're going to turn off the isolation, and I can essentially develop any complex set of expressions, and for any of these, if I'm unclear, for example, we're going to create a new one. I can also, as long as the filter is selected, I can right click, go to the expression editor. So this allows me to kind of access and see all of the different types of nomenclature and syntax that I have. So this opens up all available properties, and if I scroll down to the categories, for example, instance parameters, it shows me that for this model, I have, for example, an attenuator parameter, and so if I want to search for that, I go object P for instance parameter, constraints because it falls under the constraints category. So here, for example, my categories on the left are identity, system, materials, and appearance, and I can go, let's look at some other examples under family parameters. And you can see that all of the different properties are listed. So here, for example, I go to mechanical or material, right? So this would be object family parameter. I can search off of materials and finishes, which is the Revit name for a category of materials, and the actual property name is frame material. So I can drill down and write an expression that identifies, and I can do any mathematical or Boolean operation within that expression and use that to identify and extract very specific information in my model. So let's go ahead and cancel out of this. So we have our basic filters defined. So now we'll go to operations. So we'll go ahead and insert a new operation. For the alpha release, we're only turning on the clash. So I select my clash operation, so I can give it here a name, and I can say this is going to be structure against piping above 915 feet. So that's what we want to do. So show means yes, we're going to show the values. In the issues, I can give each issue, or let's say the operation or the reason that created an issue, a color. Here we don't have any issues created yet, and I can add individual comments. Once I have the operation defined at the bottom, I can give it additional parameters. So there's a touch distance, so this is like, think of it as like a tolerance. Now I have input A and input B, right? Because we need to clash two sets of objects. And so here I have, this is where the filters come in, right? So I select the first filter. So let's do the plumbing model, right? So those are all of our plumbing components. And I'm going to filter those plumbing components and only select those that are above 915 feet. So I have essentially, I can add any number of filters that I combine. So this allows me to have very reusable, think of them as like filter blocks or snippets of code that I can then just kind of recombine, and I can keep my individual filters very simple. And the second set is now going to be my structural model. So I have my input A, which will be all plumbing objects above 915 feet, because we're only coordinating the upper three levels against my structural model. I can also define exclusion filters, right? So for example, I could say exclude copper pipes, or exclude pipes that have a certain diameter, or any other type of parameter that's available in my Revit model. Reporter, so I'm going to say I'm reporting this issue. And let's see, did I select myself? Yes, so I selected myself. And assignee, so I can either assign to Acme Construction. So let's go ahead and assign this to Acme Construction. Severity, I can give it a severity, so we'll say medium. And a due days and a summary, so I can provide some text here as well. We've already defined the color and opacity. So we've now defined our operation. What I'm going to do now is go to the Operations tab, and we can just run it. Once the operation is run, we'll see that we have a series of issues. So in this case, there are lots of coordination challenges on this project, so we have over 7,000 issues. We can look at the issues, so we switch over to the issues, and we can see that they're assigned a number. I can still give it a summary. It was assigned a severity based on what we had set up. It's assigned to Acme Construction. The due date and all of that information is essentially as I had configured. So what we can do now is we can go and select down. So here you can see this is a W36 by 232. It's a structural beam that has a somehow a clash with a plastic socket type vent. So we'll isolate that, and essentially when we come in, we can see clearly this is the clash that we're talking about. So this is the pipe, and let's go back to here. So this is the steel structural steel member. So this gives you a good indication of how you can access this, and we'll also do the auto fit. What that allows us to do is essentially scroll down through all of the different clashes, and you can clearly see where we have those problems. So now let's go into the next aspect of issue tracking. I'm going to just increase my screen here. So this is a particular issue we'll focus on. It's for a W14 by 30 structural beam, again, against a plastic socket type of pipe. So now that we have an issue, I have several options. I can put in comments that also, especially in the collaboration mode, will be very useful. So I can say this is an issue needs to be resolved. And all of my comments, as well as everybody else's comments, get tracked. I can come in and, for example, any action that I take. So if I change this to high severity, for example, it comes in and records that action as well. So all actions, all comments of any of the users that are collaborating on this information get tracked. But what's a nice feature is now that I have this issue, I want to be able to communicate this to Acme Construction. So I'm going to go to the issue, and under issue, you can see that we have the ability to add any number of assigned views. So I'm going to go ahead and create the first view, which is just going to track this. So here I can, for example, put a comment. So I'm going to go to my callout and put my text here that would provide something. So this is one view for this issue. But I might want to provide a different perspective. So I'm going to create a second view and, for example, look at it from this side and provide, let's say, a 3D markup. So here I give it a 3D markup, give it an additional, okay, it keeps resetting because I have my auto fit set on. So I'm going to go to my view, unview the lock so that I can reset this view and come in and I'm going to re-lock the view. So essentially that's just locking the camera position. I can also prevent permanent changes, put an arrow, add text, and essentially say, move down 2 inches. The text has its own box. I can come in, make this 10 font if I want, and move that into position. So in summary, I can come back into my issue. I now have view A, view B. These can all be assigned. Makes it exceptionally easy to be able to communicate a particular issue. If I again go down my list, and let's do the, so we're just going down the list. Those others aren't showing up because I turned off my auto fit. But if we do the auto fit, essentially we come in here. As soon as we go into this view, this is view, or this issue, I have this view, plus under my issue, the other view that I had defined. So again, this gives you kind of a good overview of how that works. All of those views are then also tracked under here. I have my default project view, which doesn't go away. I have my issue view A, issue view B. All of these are tracked in addition to the ability for me to add, for example, any generic view to the project. That concludes the review of how to use the clash operation in Visicon, assign it to different participants on your project, auto-generate issues, and I highlighted some of the issue annotation and tracking capabilities. Thank you.